Hello everyone, welcome back to interviewbuddies.com. In today's video, we are going to talk about how you test your code in Python. So on my screen, you see that I have two functions written, add and subtract, and I want to test them. So how I do that? Python provides a very good library or a testing framework that can be used to write simple and scalable test cases. It can be used for both functional and unit testing, as well as for it, like it's well known for its simplicity and flexibility. So let's get started. I don't think I have PyTest installed on my machine, so if I do that, command not found PyTest, so I'm going to do pip 3 install PyTest. It should install it. So I have PyTest now. Okay, so PyTest is there, command is running, so it's all good. So the setup is complete. Now I want to create a test file for this particular code. So how I do that? So I'm going to create another file to test these two functions. So I'm going to call from math underscore operations OPE operations import add comma subtract. So this is my test file. I'm saying that from the other file math underscore operations import these two functions, right? And then I'm saying define test underscore add just to test the add, and let me save it first. I have saved this file as test underscore math underscore operations dot py. So it's a common practice to save your test files using test underscore or underscore test dot py. So there's that. So I'm going to add the testing code here. So my functions are add and subtract. So in the first one, I'm going to say that assert add, and if I'm passing 2 comma 3, the sum should be equal to 5. Okay, another assert, maybe assert add again, and let's say minus 1 comma 1, and the result should be 0, right? Similarly, another function define test underscore subtract, and here I'm saying that assert subtract and 3 comma 2, which should give me 1, and another assert minus 1 comma 0, it should give me minus 1. So these are the two test functions with assert statements in them. So now let's run this code, this test code. How I'll run this: if I run the command PyTest, it will simply recognize the test files and run these assert or the test functions. So here it, and it's saying that 2 test cases are passed. So these are the basic, this is the basic way of running the test cases. Now when you run the PyTest, it will provide a detailed output of the test results, as you can see on the screen. If all the tests are passed, you will see a summary of indicating the number of tests that pass. So for example 2 here, right, and it ran for this much time. If any of these test cases fail, it will provide information about the failure as well, and including assertions and the values which are involved. So if I have to fail a test, if I'm saying 3 comma 2 should give me, let's say 5, so this should fail here. So now it's saying that assertion error at this file, test file, at line number 9, which is this. So with this information, you can go and fix your test or code or whatever is needed, right? So that's how it works. Now the other part of this is using fixtures. So what fixtures are? So fixtures are the way to provide a fixed baseline upon which test can be reliably and repeatedly execute. They are used to set up context for the test. For example, uh, let's write a fixture to set up some test data. So I'm going to use this same file and I'm going to comment the existing functions here. And here I'm saying that import PyTest, import the PyTest framework, and then I'm saying that define input data and 2,3 return 2,3. Okay, this is the input data. Now I'm saying that this is the fixture, so I have to use PyTest.fixture. It's kind of an annotation, so which will tell you which tells the PyTest that this is the fixture. So now we can just copy these two functions defined above and then use the fixture so that we don't have to use the hard-coded data in these functions. So how it works, pass this fixture here and then say a comma b equal to input data. So the value for a comma b is coming from the fixture, right? And then it will give you this this assert. The value of this assert should be equal to 5. Similarly for subtract function, you can do the same thing. And here I'm saying use a comma b here. Use a comma b here. Okay, so now we have this. So as you see, instead of writing data like values for a and b again and again, we are just using the fixture. So let's test this out. Okay, so one test failed, cannot unpack non-iterable. So we missed something. We have to pass this input data here and then run the test again. Now it's failing on the assert, which means that a comma b subtract is not equal to 1. A is 2, b is 3, so it should be -1. We are fixing our test case here. So that's passing. So that's how the fixture works. The another part of running the test case is using parameterized test. So what a parameterized test is, you want to test your functions in a lot of data like repeatedly, and you don't want to every time hard code that. So I'm going to show you how to do that. So let's keep using the same function. Basically, I'm going to just comment this one out. So I'm going to use a decorator called as parameterized. So something like this, @ PyTest. In Java, it's called as annotation. In Python, it's called as decorator. So mark dot parameterize. We are saying that we have these parameters a comma b and then result. Okay, and in that parameterized decorator, I'm saying that if I'm passing a as 2, b as 3, the result should be 5. Similarly, another test case is if I'm passing 1 comma -1, the result should be 0. This is for addition, right? And another one is if I'm passing 0 comma 5, the result should be 7. Okay, so I have created this decorator and now I want to use it in our function, in our test function. So So similar, like the similar way I have used the fixture. So what I can do is copy, not copy, a comma b, type a comma b, and then result here. Okay, and then here I'm saying add a comma b, and the answer should be equal to result, and we can just remove this line. Okay, so this is the fixture, or this is the decorator, parameterized decorator for our addition. For subtraction, something similar. Just change the result. If I subtract 2 comma 3, the result should be -1. 1 minus 1, the result should be 2, and 0 minus 5, the result should be -5. So same data, the result has changed because it's a subtraction function. So again the same thing, subtract a comma b, and it should be equal to result, and we can just remove this line, not the function. Okay, so now let's run this, clear the screen, run it in verbose mode. So something is missing. I have misspelled it, so let's fix that. Now after fixing the spelling, run it again. Tuple object is not callable, so something is wrong because I have some syntax error here. So after that I can, okay, let's call it again. Okay, function uses no argument as a, which means that for this one as well, just replace it with this parameterized arguments. Now run it again. Something has changed. It's failing at assert now, which means we made a progress. So the issue here is in the test head function, it's saying that where 5 adds to 0 comma 5. So okay, so the result here is wrong. So 0 plus 5 should be 5, not 7. So, and it passed. So you see how you ran like the same, these two methods, add and subtract, on the multiple rows of, or you can say multiple data. All right, so that's all for today. Hope you like it. Don't forget to hit subscribe button. Thank you very much.